Today we're going to study combinations of functions. We are going to be able to determine the sum and difference of functions, determine the product and quotient of functions, and determine composite functions. Any algebraic operation can be used to combine two smaller functions together. Take this example. I want to determine what f plus g of x is. That is saying I want to take f of x and add g of x to it. Again, f of x and g of x are referring to functions. So instead of f of x, I'm going to say 2x plus 1. Instead of g of x, I'm going to say x squared plus 2x plus 1. And now I just combine like terms. All of your rules of algebra apply. So I didn't have anything to combine with x squared. 2x and 2x make 4x, and 1 plus 1 is 2. So f plus g of x is x squared plus 4x plus 2. Now let's try multiplying. This is asking us to multiply f of x and g of x together. Our equations are the same, but this process is a bit more complicated than the previous example. F of x is 2x plus 1. G of x is x squared plus 2x plus 1. Which means I have to distribute. You might also hear this process referred to as FOILing. I have to take 2x and multiply it by everything in the second expression. I also have to take positive 1 and multiply it by everything in the second expression. So 2x times x squared is 2x to the third. 2x times 2x is 4x squared. 2x times 1 is 2x. Now I've got the positive 1 to multiply to everything. 1 times x squared is x squared. 1 times 2x is 2x. And 1 times 1 is 1. And again, my rules of algebra still apply, so I just have to combine like terms now. I have nothing to combine with 2x to the third. 4x squared and x squared make 5x squared. 2x and 2x make 4x. And there we have it. F times g of x is 2x cubed plus 5x squared plus 4x plus 1. Composites of functions occur when you plug one function into another function. The notation looks like this. Looks like it says the word fog. But that's saying f of g of 2. So, starting on the inside, it's saying plug in 2 for every x in g, and then plug in g of 2 for every x in f. Let's break this down. First, we have to determine the inside. So g of 2. A very common mistake that people make is they use the wrong equation. So g of 2 is 1 over 2 minus 3. Again, plug in 2 anywhere you see an x in the g equation. And now we'll simplify it, which is 1 over negative 1, or just plain negative 1. Now that I know that g of 2 equals negative 1, I can go back to my original problem. Since g of 2 equals negative 1, I really just need to figure out what f of negative 1 is, which means that I'm going to plug in negative 1 everywhere in the f equation. So negative 1 squared plus 2 times negative 1 minus 1. Negative 1 times negative 1 is 1, plus 2 times negative 1, which is negative 2, minus 1. Combine my like terms. Negative 1 and positive 1 make 0, so my answer is negative 2. So f of g of 2 is negative 2. And that's my answer. This process is harder to understand if you don't have a number. If I just want to know what g of f of x is, I have to do a little bit of thinking. Again, you can rewrite this notation like this, f of g of x. And this is saying, for every x in g, I want to plug in the function of x. So let's start off like this. Instead of x, I wrote f of x, because that's what I want to go in place of x. I know f of x to be x squared plus 2x minus 1. So that's all in for my x, and then don't forget the subtracting of 3 in the original g equation. From here on out, it's just algebra again. Combining your like terms, negative 1 and negative 3 make negative 4. So g of f of x is 1 over x squared plus 2x minus 1. Please write down any questions that you have about this topic, and we will go over them in class.